Hello to all viewers of the YouTube channel Electrician 1. In today's video clip I will be showing you how to measure resistance. In order to measure resistance, we need to prepare a universal measuring instrument in the following manner. We need to place the black measuring cable to the port marked COM. We place the red measuring cable to the port marked ohm. After that, we need to turn on the universal measuring instrument and use the selection knob to select one of the positions in the interval marked with the letter ohm. In our case, it is a mark of 200 ohms, over 2 kiloohms, up to 200 megaohms. It should be noted that when the measuring cables are separated when there is air between them, which is an insulator, the resistance between the measuring cables is infinite. And this is shown with the number 1 on the left, which means infinite resistance. In the opposite case, when the measuring cables are connected, so their tips are touching, the resistance shown on the display will be 0 ohms. Now we will try to practically apply this and measure the resistance of one resistor. Here is a resistor whose resistance we can determine if we know how to properly mark the resistor with colors. And if not, we will now determine that by measuring. It doesn't matter which measuring cable we put on which side of the resistor. And here we measure the resistance of the resistor, and we read the value on the display. In this case, it's 0.002, but what is the unit of measurement? Since the selection knob is in the 2 megaohms position, this value means 0.002 megaohms. So we are free to reduce the range. We reduced and set the range to 20 kiloohms. And here we read a value of 2.21 kiloohms. When we further reduce the range and then perform the measurement, number 1 on the left, which we just said indicates infinity, in this case, will indicate that the instrument cannot measure this resistance. So we need to increase the measuring range. We return to the previous position, and by measuring we see a resistance of 2.21 kiloohms. Measuring the resistance of another resistor, we measure its resistance of 0.98 as shown in the display. Let's see what is the unit of measurement. Since the selection knob is at 20 kiloohms, it means that the measured value is in kiloohm, i.e. 0.98 kiloohms. In this case, we can reduce the range, remeasure, and see that it is 0.987 kiloohms, or 987 ohms. The universal measuring instrument is most often used for the so-called position beeper. The most common application here is this position marked with a note, a sound signal. If we connect the measuring cables in this position, except for the 0 that will be shown on the display, we can also hear a sound signal. What is it used for? It is used to examine whether two points are electrically connected. So they are connected by a conductive part. In this case, we can examine whether this fuse is blown or not. We put one measuring cable on one end, the other on the other, and we hear a sound signal. So this fuse didn't burn out. We'll try the same with the other fuse. There is no sound signal here, so there is no contact between the lower and upper cap. So this fuse is blown. Here we have one switch. If it is in the 0 position, there is no sound signal, so there is no contact. If we switch to position 1, we can hear a sound signal, and we know that the switch in the position is on. We can also use this procedure to determine if a cable is broken. In this case, we will test our extension cable from the plug. We will put one measuring cable on one plug connector, and the other on the extension cable. We can hear a sound signal, and it means that one conductor is continuous, there are no interruptions, and the other should be connected to the other terminals. We can hear another beep, so it's not interrupted. We still have to examine the grounding conductor. Here is the grounding contact, so we can conclude that the cable is not broken. What else can we examine here? We want to examine whether we have a short circuit somewhere between the phase and 0 in the extension cable. So, we will connect one measuring cable to the phase and another to a 0. And if a sound signal is heard, it means that this extension cord would be somewhere in a short circuit. In this case, there is no short circuit. We are checking that we have no contact with the grounding. There isn't one. This is not connected to the grounding. Also, this other connection is not connected to the grounding. Before any testing with the so-called beeper, it is necessary to check whether everything is working by connecting cables. And only then we can measure everything we want to check. Thanks for watching this video. Please share it with your friends and invite them to subscribe to the YouTube channel Electrician 1. Kind regards until the next video.